Alright, today we're in your packet. We are looking on, which we paper clipped on page 136. We're going to start with structure of the hydrosphere, and we are going to take some notes today. We're going to look at some timelines about video technology, through video of some of the different technology that's been used to explore the oceans, and the oceans still are the greatest unexplored areas of the earth because they're so vast. And if we have time, we're going to look at a video clip of some census data that was collected over many years and new species were discovered. So that is our plan today. So we're going to start by looking at the structure of the hydrosphere. And as we just said in our warm-up question, about 97% of the water found on the earth is in the ocean. And so that leaves about a little over 3% of water to be fresh water. And then fresh water is broken down into ice, groundwater, surface fresh water, which includes all your rivers, lakes, and streams, water that is in the atmosphere, and water that is in the soil. So those are the different breakdowns. So as you can see, ice is where most of the fresh water on the earth is found, and that ice, where would it be located? And it would be located in the polar ice caps and at the North and South Pole. Now, so oceans contain the most, saltwater only. Ice is number 2, and as well as glaciers and icebergs are where most of the ice is located. And then there are some areas like in Antarctica and the tundra of northern Russia where there is permanent snow areas that house water in the form of ice. Now, on your notes, you have a breakdown. You have a bar, 3 bars, that shows the distribution of water. The first one to the left, the green one, that shows the first bit of information that oceans make up 96.5% of all the water on the earth. And then you've got that 2.5 that is fresh water. And then you go to the middle bar, which breaks down the fresh water. You break down that 3.5%, then you've got the glaciers and the ice caps would make up 68.6%, and then groundwater, and then amazingly surface water, all our rivers, lakes, and streams make up such a small amount. And then the third, if we break down just that smallest percentage of surface water and other sources of water, you can see how that is broken down as well. And again, lakes make up more water than our rivers do, and swamps and marshes and other wetlands make up more than our river systems. So that to me is very interesting diagram. Now, we're going to you're going to create a graph of your own in a little while to let you decide how you want to show this distribution of Earth's water. And so I'll pass out that piece of graph paper in a few minutes, and we'll get to that. Now, the first thing we're going to do in ocean technology is we are going to look at some video clips and some timelines. And again, the ocean is the great unexplored on the earth. And we don't know as much about the ocean as we know about anything else. And some of the tools we use to learn are obviously diving. We have underwater submersibles. Some are remotely operated. They're called ROVs. Some are human occupancy, and they can be 1-man, 3-man. We have a lot of ships that are roving laboratories out on the ocean, and they send the vehicles down and they collect data. And then you also have the autonomous underwater vehicles, And so they can be pre-programmed. They don't have to have anyone on a ship remotely operating them. So those are some of the technologies that are available to explore the ocean today. Now, if we go back, through time, let's see if I can get this timeline to get bigger.
Attention to all students as you ride.
So we're going to pause for a moment and go through this website and just look at the way how ancient man and how man has always been interested in learning about the vast unknown. And so we'll pause here and go through this timeline. When we finish going through these major dates, I am going to show you a clip of the trip to the deepest point in the ocean. And James Cameron, who made the Titanic and has made many other movies, is fascinated by deep sea exploration. And he and National Geographic arranged to go down to the deepest point on the earth, which is the Marianas Trench. So these are some of the key points that came from that little timeline we just went through. The Phoenicians, an ancient civilization, they were some of the first to leave evidence that they went exploring the ocean, and they used a ship. They would have probably navigated with the stars and within not too far from the land. But the ancient Chinese discovered the compass in 1000 BC. Another important event was the invention of scuba gear, so man could actually spend time underwater and be able to breathe. In 1920, sonar was invented, and sonar was invented as a result of the problem with the Germans were sinking. I'm sorry, I'm saying that wrong. Sonar was invented so submarines could travel deep in the ocean, and we needed to be able to detect those submarines because the Germans were shooting and torpedoing from their submarines. They were torpedoing our ships during World War I and the early 1920s. And so the technology came out of a need to be able to identify things that were underneath the water that we didn't know. Now we can use it to actually use the sound waves to map the depth of the ocean. You send down a wave, a sound wave, it bounces back up. You can measure how long it took and convert that time into distance, and then map all of those points and get a view or a profile of what that section of ocean floor looks like. 1934 was that first submersible. And now, as I showed you in the pictures a few minutes ago, we have remotely operated ones, and we have vehicles with where humans go down and study. Remote sensing is another important tool used in studying the ocean, and remote sensing is where we use satellites to gather data, or it can be aircraft, but primarily satellites, and then some of the most important data they take about the oceans is surface temperatures and how the temperatures of the ocean are changing and how they follow currents within the ocean. And when the scientists then go to the actual site, which has been mapped, then we know that's called ground truthing. You go to verify the data that the satellite has collected. And some of my posters up on the wall over there beside the column with the paper towel holder on, that is an image of some remote sensing. There's also one up here. There's a smaller version of it, and that catching the current with the sea turtle on it. So we're going to pause here for a moment. Okay, this image is from Tuesday the 27th, so just a day ago, and you can see that this area here in the southern United States is what's being mapped primarily, and these are surface temperatures, so right along the coast it's cooling down, but the water is much more shallow right there in northern Florida and Georgia, South Carolina. A little bit farther out, you can see that the temperatures are still pretty warm. If you go over here in the Gulf of Mexico, you can see that out in the Gulf it's very warm, but along the coastline the temperatures have cooled, and that makes sense. If you look up here in the northeast, we just had a really bad storm and had a lot of snow, and you can see that some of the surface water there is much cooler, and the blues indicate cool, and the reds and oranges indicate much warmer water. And what is that term we learned that describes how water loses heat slowly? All right, we're going to watch this video about scientists seeing the ocean floor via sonar before we go on and finish the notes on seafloor topography. And seafloor topography is the description of the lay of the land below. So there's mountains, there's hills, there's canyons, and we're going to look at those images now, and then we will finish our notes. All right, so here are the 6 of the major topographical features on the Earth's seafloor. We have the continental shelf.
Henry Wilkerson.
And that would be when you go out on the beach and you are walking in that surf zone where the water is in and out due to the tides, and it's pretty shallow, and that's gently sloping, and you go out and you keep walking and it slopes down a little bit the farther out you get. Off the coast of North Carolina, our shelf extends out about 25 to 35 miles, and it's still continental crust, if you remember in 6th grade when you studied plate tectonics. And then when it drops off into what you call your deep zone, your much deeper water, that drop off is called the continental slope, and that part of the seafloor that's sloping down would be still continental crust, and then when you get into the deep abyssal plain, you are now on oceanic crust, and that would be your flat, deep seafloor. Along this, running around the whole center of the oceans, connecting all the oceans, is the mid-ocean ridge. They're volcanic mountains. They travel about 80,000 kilometers. In the mid-Atlantic, the mountains are actually pulling apart due to a divergent plate boundary. And you also have some standalone volcanic peaks, and if they don't break the surface of the ocean, they're called seamounts. We have some trenches, and the last thing we're going to do in our notes today is we're going to watch a video clip about James Cameron's journey down to the Marianas Trench. And it is 11 kilometers deep, and the deepest known point in the ocean. I can't say with absolute certainty that it is the deepest point because there is still some that has not been explored. So this is the end of our notes. We're going to watch the Cameron video, and we're going to do our graph, and then if we have time, we are also going to look at some work that's been done on the senses of the ocean.